Welcome back to the LLM Wiki. This is episode 8, and it is the last stop on our core journey. We have built the 4 pillars: retrieve, compile, verify, constrain, and last time we were brutally honest about where they crack. So what do you do with a pile of honest limitations? You turn them into an agenda. This episode is not a list of answers. It is a map of the questions worth chasing next, the empirical studies the whole field still needs, and a concrete research program for turning safety constraints into real infrastructure. Think of it as the to-do list this series leaves on the table. Let us walk it together, one open problem at a time. Start with the question that keeps a wiki honest over time: what happens when bad information gets in? We ran a contamination study, seeding false claims and watching them spread. A single lightweight lint, just pattern matching, gave essentially no protection. But a 3-layer defense, that lint plus provenance gating plus an adversarial review pass, cut contradicted claims from 7.67 down to 2.67, a reduction of about 2/3. And it only worked because the middle layers actually reason about meaning. The open questions start right there. What steady-state contamination rate does a living wiki settle into? Is there a herd immunity threshold below which falsehoods just die out? And what happens when an adversary adapts to your defense? None of that is answered yet. The next open frontier is time itself. How should a wiki keep up as its sources change? You have a spectrum of choices. Recompile the whole thing in batches, cheap but stale. Update page by page, more responsive but more bookkeeping. Or go all the way down to individual claims, precise but expensive. Nobody has mapped when each one pays off. And underneath sits a cost problem: which incoming material is even worth ingesting? A simple word frequency score works well for English technical text. But the moment you ask a language model to judge ingest value, it saturates. In the early life of a wiki, when the page count is low, almost everything looks new and important. Learning to budget attention as a wiki matures is wide open. Now put several agents around one shared memory: a planner, an executor, a supervisor, each reading and writing. How do they collaborate without corrupting each other? Role-based memory is the natural frame: a clinical agent, an administrative agent, a research agent, each contributing in its lane. But recall the hard lesson from last episode: some conflicts are perspective dependent, and nobody is wrong. So the deep question is representation. Do you drive the agents toward a single consensus view, or preserve each perspective side by side? The honest answer depends on who is reading. Another agent that needs one clean answer wants consensus, a human who needs to see the disagreement wants preservation. Making that choice automatically is unsolved. None of this progress means anything without a way to measure it, and that is maybe the biggest gap of all. We proposed wiki health, 4 tiers of metrics, paired with adversarial validation that injects 6 kinds of corruption and checks whether the wiki notices. Why adversarial? Because of one humbling result. We removed citations from a wiki, gutting its provenance, and every static quality metric stayed green, on both wikis we tested. The damage was invisible until we attacked it on purpose. That blind spot is the whole case for adversarial benchmarks. And it points straight at security, a surface that plain retrieval never had, poisoning the wiki at ingest time, injecting prompts at query time, and exploiting drift over many rounds. A persistent memory is a persistent target. That covers the empirical questions that span all 4 pillars. But there is one pillar whose research program is so rich it deserves the rest of this episode: constrain. The living constraint oracle from episode 6 was just the seed. The full vision is to make safety constraints a reusable layer that any agent, in any domain, can stand on. And that breaks into a structured program: 7 projects across 4 tiers. A foundation that builds the constraint layer. An extension tier that grows it across reasoning, planning, and multiple agents. A hardening tier that attacks and tunes it. And a theoretical capstone. Let me walk you up that stack, because the order matters as much as the parts. The foundation is a project we will call Wiki Shield. Episode 6 showed constraint compilation working in one clinical setting. WikiShield asks whether that idea generalizes into infrastructure. The recipe, an automatic protocol that compiles wiki pages into Prolog or Z3 rules, feeding a 3-level gate, hard block for genuinely unsafe outputs, soft warning for the borderline, and pass for the rest. The research is not in the plumbing, it is in the measurement. You would track precision. When the shield blocks something, is it truly unsafe? And recall, of all the reasonable outputs, how many sail through untouched? A constraint layer that blocks too much is as useless as one that blocks too little. WikiShield is where you prove the whole approach is real. On that foundation sit 3 extensions. Consistent chain moves from after-the-fact checking to live intervention. After each step of a reasoning loop, you check the intermediate conclusion against the wiki and step in the moment it contradicts. The hard part is knowing which claim is relevant right now, and paying for the check in latency. WikiPlanner guards whole action sequences instead of single steps, compiling timing rules like, if A comes before B, then C is forbidden, into linear temporal logic that prunes a planner's search. Think emergency shutdown order, or a multi-step treatment plan. And multi-agent wiki makes the shared memory safe when many agents write at once, conflict protocols, provenance-weighted write trust, and a firewall so one agent's bad knowledge cannot contaminate the others. Build a shield, and you immediately need 2 more things, something to attack it, and a way to tune it. Wiki breach detection is the attacker, the deliberate adversary to WikiShield. An agent can produce output that passes every formal check yet violates the constraint spirit. Tell it not to diagnose, and it writes, your symptoms are highly consistent with diabetes, never using the word, but doing the thing. Wiki breach detection defines and measures that semantic evasion as a red team framework. Any deployed constraint layer needs exactly this. Its partner, constraint calibration, asks how tight the constraints should even be. A medical agent wants them brutally tight, a creative writing agent wants them loose. The goal is to infer the right tightness from the wiki's own content, its risk density, its uncertainty, instead of hand-tuning thresholds. At the top of the stack sits the most ambitious idea, causal wiki. Every constraint so far is reactive, X is forbidden, so block X, causal wiki is prospective. It stores causal knowledge, doing X tends to cause Y, and Y is dangerous, so the agent avoids X while it is still planning, before any harm is possible. That means a causal graph plus intervention effect estimation, borrowing directly from our Koopman and offline reinforcement learning work, feeding a forward-looking cost-benefit check. It is the deepest theoretical thread in the series, joining causal inference to agent safety. Now step back and see the whole map: foundation, extension, hardening, theory. If you start anywhere, start with 2, WikiShield and wiki breach detection. One proves constraints work, the other proves they resist evasion. Only together do they make a complete safety argument. So, after all of it, where does this whole pattern actually earn its keep? Be precise, because overselling helps no one. The wiki delivers when you need cross-document synthesis, when contradictions must be caught rather than averaged away, and when you query the same knowledge often enough to amortize the cost of compiling it. It fails, and you should reach for plain retrieval instead, on small corpora that fit in a context window, on exception-dense domains where every case is special, and on simple lookups where compiling is just overhead. The honest verdict is not, wikis beat retrieval. It is, wikis and retrieval solve different problems, and knowing which one you have is the first real skill. 2 reflections before we close. The biggest surprise of this whole program was not planned. We set out to organize knowledge, and the thing that excited us most was the living constraint oracle, knowledge that does not just inform an agent but actively governs it. We did not see that coming. And the most ambitious direction forward is the neurosymbolic marriage, language models for flexible understanding, formal logic for guarantees, the wiki as the membrane between them. But hold both of those lightly, because here is the caveat that colors everything: our studies were small to medium, and several ran on semi-synthetic data. Treat all of it as a strong beginning, not a finished science. And we are not asking you to take any of this on faith. The code is open. The data is open. 5 complete knowledge bases ship with the work: an introductory AI course, a calculus text, a Java programming guide, a computer networks reference, and a cultural heritage wiki for the Himudu and Liangzhu sites. They span the easy cases and the hard ones on purpose. Clone them, break them, contaminate them, attack them, and check whether our numbers hold on your machine. An agenda is only worth anything if other people can pick it up. So consider this whole episode an invitation. Everything you would need to start is already on the table. And that brings our core journey to a close. 8 episodes ago, we started with a simple discontent: retrieval hands an agent a pile of documents and hopes for the best. We asked what it would mean to give an agent real memory instead, and we built the answer in 4 pillars. Retrieve, to find what matters. Compile, to turn documents into living pages. Verify, to make the knowledge check itself. Constrain, to let that knowledge govern what the agent may do. None of it is finished. All of it is honest. If this series did its job, you no longer see a wiki as a humble pile of notes, you see living semantic memory, and a research frontier wide open in front of you. Thank you for walking it with me. From the LLM Wiki, go build.